I'm Tom from the Physics Classroom with another video from our Task Tracker series titled Writing a CalcPad Problem. As a fair warning, this video is probably not your best video for a teacher interested in learning how to use CalculatorPad. There are other videos that are precursors to this one, and I've left links to them in the description section of this video if you'd like to review those first. This video is really designed for that Task Tracker teacher who would like to take their CalculatorPad skills to the next highest level. In the video, I'll be discussing what is CalculatorPad, how do you access the Problem Builder of CalculatorPad, how do you use that Problem Builder to write your own problem, and how can you take that new problem and include it in your own problem set and even share it with colleagues. Let's get started. For the last 14 years of my teaching career, I used a commercial service that you'd likely recognize the name of. It was exceptional at creating problems that had random numbers in them and delivering them to students and automatically grading student answers. It would give students immediate feedback and opportunities to correct their errors. It was an exceptional tool around which we created several courses at our school. The problem was the price tag was rather steep. In the spring and summer of 2022, I worked with our programming team at the Physics Classroom in order to create a similar tool that did many of the same functions but had a few less bells and whistles associated with it. That tool had to be affordable to teachers at as low as 80 cents per student and compatible with our Task Tracker system in order for teachers to track the progress of their students. And at the same time, the tool had to be free for students to practice as much as they wished. Our goal was to equip the tool with loads of ready-to-use problems organized into very short problem sets, and at the same time, give teachers the ability to customize those problem sets, to shorten them or combine them, and even to write problems of their own. In this video, we're going to be focusing on that last part, how to write a CalcPad problem for inclusion in your own custom problem set. The first step to writing your own CalcPad problem is learning how to access the so-called Problem Builder of CalculatorPad. Log into your account and click on the Classes link. Then find a class that is going to be using CalculatorPad and open that class. Look for a CalculatorPad topic or create a new topic that is a CalculatorPad topic. I'm going to open CalcPad 1D Kinematics. When I do, you'll notice a few things. First, the assignments under 1D Kinematics are listed here, and second, there's a blue Problem Library button. The Problem Library is where we store all of your problems. Every problem has an owner. The owner could be the Physics Classroom, or it could be you if you've written your own problem. If you open the problem library, you'll see all the problems that you've written there if you select Mine from the problem owner. If you select Public, you'll see everything that the Physics Classroom has written, and if you select Subscription, you'll see everything that any teacher in your subscription has written. Now what I'm going to do is click on the New Problem button, and when I do, the Problem Builder opens. In the breadcrumbs near the top of the page, you'll notice it says Problem Builder, and this is where you write your problem. Now I'd like to show you a second means of opening the so-called Problem Builder within CalcPad. Back in one of your CalcPad topic areas, open a problem set that already exists. Then launch that particular problem set assignment inside of the so-called Assignment Builder. Now as you scroll down, you see all the problems within that assignment. Next to every problem is a couple of buttons that are plus and minus button. Minus will delete this problem from your problem set, and plus will add a new problem to your problem set. If you click on the plus button next to problem 3, you'll add another problem that shows up as problem number 4. I'm going to click on that plus button, and I'm given this option. I can cancel out, I can create a blank problem, I can select an existing problem that we have written or you have already written, or add this problem again as a duplicate of problem number 3. If I select Create Blank Problem, then the Problem Builder opens within the Assignment Builder. There you see it there, and from this location you can begin writing your new problem. No matter how you write the Problem Builder, the result is the same. You'll be writing a problem that can be used in any problem set that you wish. When I start to write a CalcPad problem set with a collection of my own written problems, I begin doing a lot of the preliminary work outside of CalcPad in a word processing document. I begin to accumulate the problems together and give them names, and then think about how I'm going to assign variables in the problem. This is the first problem that we're going to write together. Now you'll notice there's 3 numbers in the problem. I want those numbers to become variables. One of them is the initial velocity, one is the final velocity, the other is the time. And so my variable names are simply going to be VI, VF, and T, and I'm going to insert a variable in place of those numerical values in my problem statement. I'm going to tell CalcPad how to randomize between a minimum and a maximum value for the ranges for each of these 3 variables. I'm going to call them VI, VF, and T. So the problem you just saw in Microsoft Word is going to be entered into the CalcPad's Problem Builder. So let's talk a little bit about the anatomy of the Problem Builder so you know what parts of the problem go where. First, you're going to need a problem name, and the problem can't be saved unless you first have a name associated with it. Then there's the place where you put the problem text about the race car accelerating uniformly. It goes right in here. There's a little panel of buttons that allow you to do some WYSIWYG formatting of the particular problem text. If you wish to include an image, you can. You do it by including the URL and placing it here, and there's some buttons for aligning that image to the left, to the right, above or below the problem, or between the problem and the problem part. And there's some sizing buttons there as well. This is the so-called parts area. If you have 2 parts, you're going to have to add 1 by hitting the plus button, and every problem has at least 1 part, that is 1 answer blank. If you tap on the edit or pencil icon, it opens that part up in the so-called Part Builder. Here's where you enter any text to the part. There's a place where you can format your equation using these sets of buttons, and there's an answer label and a units label with some formatting icons there as well. I can exit the Part Builder back to the Problem Builder by hitting that button. And now if we continue through the Problem Builder, we'll notice there's a place where you can put some help text for students. Something like, see example 3 from page 56 of your packet for help on this particular problem. You can enter some links to a video, an audio, or a web page. You can put some tags in for the problem that makes it searchable. For instance, if you're writing a problem set that you're calling 1D kinematic set 1, that can be a tag. It must be 1 complete word with no blanks in between. You can also use our tags. Our list is kind of lengthy, but you can begin to type into this field, and as you do, it will select out those tags that we already have in existence that you can use to tag your problem and make it searchable by tag. Finally, you have some difficulty levels that you can select here to identify the difficulty level of the particular problem. Over on the right side of the Problem Builder, you see where the variables are selected. An independent variable is a variable that Task Tracker will randomize between some minimum and maximum range value. Once you add an independent variable, it will the range boxes will come up that you can format. Exclusions mean that for the range that you've set, you'd like to exclude a particular set of values from within that range for whatever reason. And finally, a dependent variable would be a variable that simply depends on whatever independent variable you've already set. For instance, you might have a mass being randomized, but you also want to have access to the weight of that particular object. And so you could set up a dependent variable that is the weight is the mass variable multiplied by the value of g. This is the anatomy of the problem builder. Now let's learn how to take that problem and input it into the problem builder. Now I'm going to take text from my Word document and place in the appropriate fields of the problem builder. I'm going to put my problem name here. I'm going to take my problem statement and place it right here as my problem text. And now I'm going to create some variables. I have 3 variables to create, one for each of the 3 different numerical values in the problem. Over here, I add my first independent variable. I give it a name. My name is VI. And now that I've given it a name, the range pops up. The value was 18.5, and I'm simply going to randomize, entirely up to you, from 16 to 20 meters per second. And there's an increment value here, and you tell Task Tracker what increment you want to divide that range into. So I'm choosing 0.1. That means that there are now 40 values between 16 and 20 that Task Tracker will pick from at random. The smaller number you put in for the increment, the more values that you will have that Task Tracker can choose from. Now I'm going to select my second independent variable, which will be VF. The numerical value in the problem statement is 46.1. I'm going to pick a larger range here. I'm going to go from 40 on up to 70, which may be a little bit extreme on the 70. And I'm going to, again, increment by 0.1. So from 40 to 70 is an amount of 30 meters per second, and incrementing by 0.1 gives Task Tracker 300 different values to select between. Now finally, I'm going to do my last variable, which is the time. I'm going to try to make it relatively realistic, and so I want to get it on the top end an acceleration of around 10-ish or so. And then on the bottom end a little bit less. So if I think about the change from 16 to 70, that's the maximum increase in the velocity. If it does that in, say, 5 seconds, the acceleration will be slightly higher than 10. That's kind of what I want. So my highest value for my time is going to be 5, and I'm just going to pick 4 for my lowest value, and then I'm going to pick as my increment 0.01. Now the increment not only determines how many possible values there are between the min and the max of the range, but it also determines how many significant digits there are. So by picking 0.01, it's going to express this numerical value out to the hundredths decimal place. Another option would be, if you don't want that many increments, is you could go 10, and 10 will also express that numerical value for time out to the second decimal place. I'm going to keep it at 0.01, and you can go 0.02, 0.05, anything that you happen to wish for. So now I have my variables, and I need to put them into the problem statement. So I'm going to select the 18.5 and replace it by a variable. You'll notice there's a variable drop-down menu, and inside of it will be the 3 variables you picked plus one other. The one other happens to be the value of G, which is either going to be probably 9.8 or 10, and you can control that in your edit profile settings of your account. If you want us to use G equal 10, we'll use G equal 10. The default is 9.8 though. Well, you pick it. Anyway, I want to pick VI for my first variable. For the 46.1, I want that to be my VF, and for the 2.47, I want that to be my time. Okay, so now I have the problem statement all set up. Now I want to do the parts. I have a 2-part problem. This is what it looked like. And I'm going to take that first part, determine the acceleration of the car, and I'm going to enter that into the part builder. So down here we see the parts. I'm going to hit the pencil icon to open the first part and enter, determine the acceleration of the car there as the problem text. And then the second part was determine the distance traveled. So I'm copying it, I'm going to paste it in the second part. There's a couple ways to get to the second part. You can go back to Problem Builder, and then you can, at that point, add the plus to add the second part, Or you can just as easily go add part right here, and we'll add the part for you right inside of the part builder, and I'm going to put determine the distance traveled. Now you'll notice the previous part button there and the next part, so I can toggle back and forth between the two parts. I'm going to go back to the part 1. I'm going to put in an answer label that shows up in front of the answer blank. Anything you want there, you can put A, you can put acceleration equal, anything that you wish, and I'm going to give it a unit, and you got options there of meter per second, and since we do have a formatting icon of superscript, you could also go meters per second squared. Now I'm going to go to part B, where it's the distance traveled, and I'm just going to type distance equal and then meters for the unit label. Okay, now I'm ready to write the equation for the two parts. I'm going to go back to part A, determine the acceleration of the car. And I knew the VI, I knew the VF, and I knew the T. So I'm going to put my equation right in there. It's the delta V divided by the T. So I'm going to use all of these buttons here. This will be an easy one. There's my parentheses for VF minus VI. And now for the VF, I just select it from the variable menu. Now as I do this, I can use the minus, the minus button to go subtract, or I can simply type that in from my keyboard. It doesn't matter. It accepts both inputs. And then VF minus the VI, parentheses, divided by the time. So you can see how easy it is to create an answer formula for your particular problem. Now I'm going to go to part B, where it's determined the distance traveled, and that's simply the average velocity divided by the time. I knew the VI value, so I select it from the variable drop down. I'm going to add the VF to it, parentheses close, divided by the 2. Again, I can type divided by 2 from my keyboard, or select it from the buttons that we have here, and then I'm going to multiply by the time. Now that your problem is saved, it's a wise idea to tap on the Preview Problem button and view your problem in the previewer. Make sure it looks the way you want it to look. Make sure numbers got randomized. Tap into the acceleration in the distance field, calculate the answers, and submit, and make sure that you got the answer correctly. Now once all that's done, tap on the button to go back to the problem builder. Now let's learn how to add an image. I'm going to go off to Google Images and do a search for race car images, just as an example. So what I'm going to look for is a free image. So I'm just going to kind of scroll through the list till I find something that looks like it could be free, and then I'm going to select that particular image. What I want to get from the image is the image address. Now I can return to my problem builder, and where it says image URL, I'm going to insert the image there. There's the image, and I'm going to decide where I want it. I want my image to be to the right of the problem. I can always preview it, and I want it to be kind of a medium-sized image. Save your problem, then preview. All right, that's not too bad. Close enough for the government. Back to the problem builder. And by the way, you can make adjustments to get that to look any way you wish. Now I'm going to go down where it says help text, and I'm going to put some help information there. The help that I'm going to put is something like see the slide deck notes from Wednesday for help on how to solve these problems, or something like that. Anything you want, any hints, anything, it's entirely up to you. I can select some tags, for instance, kinematic equations, add as many as you wish, and then I can select the difficulty level, whatever you call medium difficulty, whatever that problem happens to be. Add a help link if you wish. If you do click there and decide not to add the URL, you'll have to remove, or you won't be able to save this particular problem unless you have a URL for the help link. Okay, now save your problem and you're done. Once you are satisfied with the look of your problem, tap on the Close button up in the breadcrumbs area of the page. The Problem Builder will close and you'll be back in your problem library. You should be able to scroll through your problem library and see the problem you've just written. There are 2 things about that problem that you need to know in order to include it in your own assignment or to share it with a colleague. First, if you wish to share it with a colleague, you can copy the ID number for the problem and email that to your colleague. They can enter that ID number in order to access the problem. If they're in your subscription, they can also access the problem from the name of the problem. Now let's close out the problem library and go back to my CalcPad class. I'm going to open up one of my CalcPad topics, 1D kinematics, and I'm going to open the problem set to include this new problem in my problem set that already exists. I launch the assignment in the assignment builder, and I'm going to put this problem after problem number 1. So I go to problem number 1, I tap plus to add a problem. I want to select an existing problem because the problem now exists. I'm going to come here to the search area to search for problems. I'm looking for my problem, and I'm going to search for all of them because I don't have too many. And there it is right there. I'm going to select the problem and add the problem to the problem set. It now shows up in my problem set as problem number 2. If I'd like to move that downwards or upwards, I can use the up-down arrows to move it. There it is, the first problem of my CalcPad problem set. Your friend can do much the same, your friend or colleague can do much the same thing. Click the plus sign to add the existing problem, and then they can enter the problem text or the ID number you shared with them, and they'll locate that problem quite quickly. There is a learning curve to writing your own problems in CalcPad, but once you've written a few of them, you'll be amazed about how quickly you can write them. If you have a question or comment on this video, please leave it in the comments section below. Or you can find our contact email on the Teacher Resources page of your account. Send us an email. We're always glad to help. I'm Tom, and I thank you for watching.